Let's discuss about refining of metals. Refining means purification of metals, removal of impurities from metals. See, the method of purification, several methods are available, but the method you choose for a particular metal depends upon not only on the nature of metal, it also depends upon nature of impurities associated with the metal. I'll first put the list of various types of methods available for the purification of metals, then we'll discuss one by one. Important methods. Number one, we have distillation. Number two, liquation. Number three, electrolytic refining. Number four, vapor phase refining. Vapor phase refining. Number five, zone refining. Number six is pooling. These are the various methods of purification we are going to discuss here one by one. We'll start with distillation. First, look at the list once again. Distillation, liquation, electrolytic refining, vapor phase refining, zone refining, and pooling. The method we choose depends on nature of metal and nature of impurity associated with the metal. The first method we are going to discuss under refining of metals is distillation. Distillation technique is applicable for volatile metals, applicable for zinc, cadmium, mercury. These metals are volatile metals. Their boiling and melting points are low. So for these metals, we make use of distillation technique of purification. We get rid of non-volatile impurities. Here, impure metal is heated. Then you get vapors of the metal. Then the vapors are subjected to condensation, and you get pure metal. The impure metal is volatilized by heating. You get vapors are collected and condensed to get pure metal. Impurities are left behind. It is very simple method and applicable for those metals which are highly volatile. Their melting points and boiling points are low. The next method we are going to discuss is liquation. In this method, we transform the metal into a liquid. The liquid flows down and the non-volatile impurities or high melting impurities are left behind. Look at the method. You keep the metal on a sloping surface. Right. This is where you have heating. This is furnace. This is where heating is done, and then the metal is placed here. It melts and it flows down and gets collected here. Impurities are left behind here. So this method is applicable for those metals which have low melting point. Example is tin. Tin is generally purified by this method called as liquation method. Metal is melted, it flows down as a liquid, impurities are left behind. This is a simple illustration of liquation process. That's liquation. Next. So far we have discussed about two methods. One is distillation. Distillation is applicable for metals which have low boiling points. Examples zinc, cadmium and mercury. And then the next method we have discussed is liquation. Liquation is applicable for metals having low melting points. Very popular example is tin. Its melting point is very close to 300 degrees Celsius. Gallium also can be purified by this method. Melting point of gallium is somewhere around 30 degrees Celsius. Cesium is also very low melting substance. Then you have electrolytic refining. Here we make the impure metal as anode and the pure metal is made cathode, and the salt of the same metal, soluble salt of same metal, is used as electrolyte. Look at this method. An impure block of metal is used as anode and a pure strip of pure metal acts as cathode. This is the electrolyte. It contains, I'll try to explain you with the help of copper. We'll take this is anode and it is impure copper. This will act as anode. And this is a strip of pure copper. This will act as cathode. And in the electrolyte, you should have, this is aqueous copper sulfate, which acts as electrolyte. Now let's see what reactions take place at the electrodes. Remember, the electrodes are active electrodes. Copper electrodes are active electrodes. When you use active electrodes in aqueous solution, anodic oxidation takes place. So the metallic copper of the anode will get oxidized to cupric by losing 2 electrons. This is what takes place at anode. Anodic oxidation takes place. This will decrease the mass of anode. And then see what happens at cathode. These 2 electrons pass through the external circuit and they reach cathode. At cathode, cupric picks up those 2 electrons and gets reduced to copper. So in this way, mass of cathode keeps on increasing and mass of anode keeps on decreasing. All the impurities which are present in this will fall down here as anode mud. Anode mud consists of costly metals like gold, silver, etc. This will fall down. Copper gets oxidized to cupric, enters into solution, then it is picked up by cathode. Cathode grows in size as the time goes. So this is electrolytic refining, applicable for copper, applicable for silver, applicable for lead, zinc, gold, etc. So for most of the metals, but remember, this is not applicable for active metals. Generally, this is not applicable in the original form. When you use aqueous solution, obviously it will not be useful for active metals, but for most of the metals this works. I have given the examples of copper, silver, lead, zinc, gold. These metals can be comfortably purified by electrolytic refining. I'll just remind 2-3 points. Impure metal is made anode, pure metal is made cathode, and the soluble salt of the same metal acts as electrolyte. This is electrolytic refining. Impurities settle down as anode mud. As time goes, the mass of anode decreases and the mass of cathode increases. Well, the next method we are going to discuss is vapor phase refining. Vapor phase refining. Let's learn about vapor phase refining. Under vapor phase refining, we have 2 examples to discuss. Number 1 is Mond's process. Mond's process is used for the purification of nickel. Nickel metal can be purified by this method, Mond's process. It comes under this category of vapor phase refining. You have an impure metal nickel, and we know very well that nickel is a non-volatile metal. When you react it with carbon monoxide, it transforms itself into a molecule NiCO taken 4 times. This is volatile. So here nickel is associated with impurities. Both impurities and nickel are non-volatile, but when you pass carbon monoxide, nickel alone will react with carbon monoxide and transforms itself into a volatile substance. Now collect it separately, then heat it. Recover the volatile fumes of nickel tetracarbonyl, heat it, and you end up with Ni plus carbon monoxide, which can be reused. So this is how nickel is purified by vapor phase refining, and the method is called as Mond's process. Nickel, impure nickel, is made to react with carbon monoxide. Nickel transforms itself into a volatile substance, nickel tetracarbonyl. This is collected separately and heated to decompose it and recover pure nickel. This is pure nickel. This process is described as Mond's process. Another example of vapor phase refining is Van Arkel process. Let's look at the example, Van Arkel process. It's again a case of vapor phase refining. We have just now talked about Mond's process. We are now going to talk about Van Arkel process. This is applicable for zirconium and titanium, two metals, titanium and zirconium. These can be purified by vapor phase refining, Van Arkel process. Here, the substance is made to react with iodine. You get ZrI4. This is volatile. I'll try to justify what makes it volatile. See, iodide is a large anion, and Zr plus 4 has very high polarizing power because of plus 4 charge, and there is a large extent of polarization taking place in ZrI4, and that makes it predominantly covalent. And because of covalent nature, it is volatile. You know, covalent substances have low melting and boiling points, so it is volatile. So you heat this substance and collect all the ZrI4, and then ZrI4 is heated separately to get Zr, and iodine is recovered as such. So the idea is to transform the metal into an volatile substance, and the volatile substance comes out. It is collected separately and it is heated to recover the pure metal. This is pure metal, and iodine is again recovered. This is recycled. Similar method is applicable for titanium also. Zirconium and titanium belongs to the same group. They belong to fourth group, 4B group of, they belong to 4B group. In the transition series, they belong to 4B group. Their maximum oxidation state is 4, and they can be transformed into tetraiodide, which is predominantly covalent, and being predominantly covalent, it is volatile and it can be recovered as fumes, and these fumes are heated to recover the pure metal. In a similar manner, titanium reacts to give tetraiodide, and the tetraiodide of titanium is heated to recover pure titanium. That is Van Arkel process, applicable for zinc, zirconium and titanium. The next method for the purification is now zone refining. Zone refining. This is applied for germanium, gallium, silicon, boron. These substances are purified by zone refining, and let me make it clear for you, zone refining gives you a metal with high purity. Ultra pure metals. Ultra pure means the impurities will be in parts per million. Such metals can be obtained by zone refining. Now, why do we need ultra pure metals? These metals, these substances are used in making semiconductor devices. So even a small amount of impurity will cause large difference in the electrical properties. So we need ultra pure substances of this type. Either they are used as doping material, or as in a semiconductor device, you know, silicon is doped with trivalent impurity like boron or gallium, right? Zone refining. Here, the metal is transformed into a rod, and then this is placed in a chamber. In this chamber, we have inert gas, say neon. We use a circular heater. This is a circular heater. Now this circular heater is moved in this direction, several times. From here, we constantly circulate inert gas, say argon or neon. It is constantly being circulated. And we are using a circular heater. This is the metal rod which is to be purified. Now, when I move the circular heater, let us assume that this is a metal rod and this is the circular heater. When I move this, what happens, the point where the circular heater is exposing the metal rod, that portion will melt. And when it is moved, the adjacent layers start melting and this molten layer starts crystallizing again. During that, the impurities will fall into the adjacent layers which are transforming into liquid. Okay, I'll tell you once again, the molten part is being moved in one particular direction. So when the molten part is crystallizing and the adjacent solid part has started melting, the impurities fall down into the molten part every time. So you move the heater in one particular direction several times. You go up to here, you switch off, come back, again go like this. So all the impurities will be driven to one corner, then discard that corner. That becomes ultra pure. So that is what is done here. So ultra pure substances, ultra pure metals are obtained by zone refining. Zone refining, we use a circular heater and the metal is made into a rod and the circular heater is run across the length of the rod several times. All the impurities are driven to one end and it is discarded. Let's discuss about the next method of purification, poling. Poling is for copper. See, one of the steps involved in the extraction of copper is auto reduction. Copper sulfide is there. You pass oxygen and transform it into copper oxide and copper sulfide. You try to see to it that you transform part of it into copper oxide and rest of it is still in the form of sulfide. Then copper sulfide and copper oxide react to give copper metal and sulfur dioxide. This is called auto reduction. So copper is obtained by auto reduction. So one of the impurities which is expected to be present in this is copper oxide. This impurity is expected to be present in the copper which is obtained by auto reduction, expected impurity. So to remove this, we do what is called as poling. Now I'm going to talk about poling. So first, before learning about poling, we should know what impurity we are facing. In the metal copper, we are expecting some copper oxide to be present and some other volatile impurities are present. Dissolved oxygen may be present, dissolved some arsenic oxides are, This is molten metal, say copper only, because poling is applied for copper only. It's an old technique. We use green wooden logs. Green wooden logs, and the molten metal, molten copper is thoroughly stirred using these green wooden logs. So the hydrocarbon which is produced, the heat of the molten copper will allow the hydrocarbons of the green wooden log to come out, and when they come out, they cause reduction of copper oxide to copper, and this oxygen will burn the hydrocarbons present in the wooden log, and that comes out as volatile fumes. And it is also causing stirring effect. Stirring is being done with green wooden logs. So the mass becomes homogeneous. All the volatile substances which are present they escape out, and you get all the copper oxide transformed into copper. The hydrocarbons reduce them into copper. So poling is a technique used for purification of copper, one stage of purification of copper. Ultimately, it is purified by electrolytic refining, but before electrolytic refining, we prefer doing poling so that we ensure conversion of all the copper oxide into copper. With this, we complete this part of metallurgy, that is refining of metals. We have discussed about 6 different methods of purification of metals. We have talked about distillation, we have talked about liquefaction. We said distillation is for low boiling metals. We said liquefaction is for low melting metals like tin. Distillation is for zinc, cadmium, mercury. We have talked about electrolytic method of refining of metals, where we say impure metal is made anode and pure metal acts as cathode. And then we have talked about vapor phase refining, where we transform the impure metal into some volatile compound, and the volatile compound is separately collected and heated to decompose it to pure metal. And then we have talked about Mond's process and Van Arkel process under vapor phase refining. Van Arkel process is applicable for titanium and zirconium, whereas Mond's process is for nickel, purification of nickel. We have discussed about zone refining, and we said that zone refining is done for those substances which are required at high purity, ultra purity, and in zone refining we use a circular heater, and the metal rod is purified by moving the circular heater from one end to the other end several times. And then finally we discussed about pooling is a method which it's an old technique used for copper. Any traces of copper oxide present in the molten copper are removed by stirring it with wooden logs, green wooden logs, because the hydrocarbons are required there, which will burn off and oxidize, reduce copper oxide. They themselves get oxidized, they reduce copper oxide to metallic copper. That's all regarding refining of metals.